Hello, so good afternoon, everybody. We will continue here today on the chapter about age and sex composition. And more specific, in the last class, I showed you this graph, and I had showed in the previous lecture as well, kind of with the general trend of more developed countries or regions as a whole. They have sex ratios, like the overall sex ratio in the population below 100%. So that means more women than men. And less developed regions, and they have more men than women in general, above 100%, the sex ratio. And I started talking about the specific example of South Korea. And in this case here, we are talking about just 1 year of data for South Korea related to sex ratios, but we break them by age groups. And just to understand how there is a lot of variation as we talk about people with different ages in the country. So more boys are born than girls. So the sex ratio of children between 0 to 4 is above 100%. So that means between 0 to 4, they are around 113 boys for every 100 girls. But this sex ratio tends to decline as we look for older people. And by around the age of, but doesn't decline so fast. And by around age 50, 54, right after that, we start to see more women than men in South Korea. And of course, that's based on data from 1995. But this is just to show that although the country might have a preference for boys being born, exactly because that's a society that there is more gender equality, women have also access to education, to good jobs, and good health services and everything that will make them, as usual, have lower levels of mortality, live longer, in other words, higher life expectancy at birth, and men dying earlier than women, you're going to see a decline in the sex ratio for the older age groups. And that doesn't happen for all the countries. The other example that's shown in the textbook is for the United Arab Emirates, that we see for all age groups, first thing, for all age groups, sex ratios are above 100%. So that means more men than women in all age groups. But the level in which you have many more men than women is the opposite. It starts to increase a lot in labor ages. And then after retirement ages, it declines a lot, right? So here you tend to have still more men than women, but not as much as you saw in these labor ages. So I mentioned before for South Korea, the really high levels of sex ratio in younger ages is related to preference for boys than girls being born. Why do you think here in the United Arab Emirates, the sex ratio does the opposite, increases so much around labor ages? So many more men in the society than women, and then afterwards it declines. Because that's a country that needs a lot of immigrants to work in their oil industry. And a lot of these immigrants that go to the United Arab Emirates to work on those jobs, they tend to be men, right? And we see that that increase is really related to labor ages. Exactly when these people are working, the sex ratio increases a lot. And then afterwards, as they retire, they might go back to their home countries, then the sex ratio tends to decline in older ages. So each country has a different dynamic. And a simple graph like that for one year, but broken down by age groups, give us an idea of how the society is organized in terms of number of men and women. We can break down this graph here of sex ratio, because here pretty much dividing men by women by age groups, right? So instead of dividing them, men and women, by age groups, they just put men and women side by side. And instead of like showing vertical, like in columns, let's show in bars. And that's exactly the age sex structure, right? So in this case here, it's telling the same story as the previous graph, but in this case, instead of dividing the number of men by the number of women in each one of the age groups and getting the sex ratio at the sex ratio in that specific age group, we show the two groups together, men and women. And we see exactly the same thing. The number of men around labor ages is much higher than women, exactly because this country attracts a lot of male workers to work in their oil industry. And this graph here is from 2000. This one here is from 2015. But you kind of see a consistency over time. That's how the society has been organized and set up for this all these last years and decades. Okay. So it's just to show that with a really simple measure, sex ratio, we can do analysis by year. If we get the whole population divided, the whole population of men divided by the whole population of women, and we can get variation by year in that graph in which the horizontal axis was year, but we also can get this variation by age group in which the horizontal axis are our age groups, okay? And one of the sex ratios that we talk a lot in demography is specifically the sex ratio at birth, focusing on how many boys and how many girls are born in a specific country or in a specific population in a specific year. Most societies have sex ratios at birth of around 105. So that means 105 boys are born for every 100 girls. So that's usually the measure that we have, let's say the normal sex ratio at birth across countries. But specific countries like China, Taiwan, South Korea, India, and several other Asian countries, they have been reporting really, really high sex ratios at birth since the 1980s. And the main thing is exactly a preference for boys. And when the couple realize that the woman is pregnant with a daughter, they they pretty much pass through an abortion. So it's the main intervention is prenatal sex identification, followed by gender-specific abortion. And that makes this biological normal of 105 not being observed for these countries. For these countries, the sex ratio at birth is higher than 105, right? So just China and Taiwan have a Confucian patriarchal tradition where some preference is strong and is still going on in the countries even nowadays. Birth planning policies, socioeconomic changes, and industrial transformations have been responsible for the rapid decline in fertility. And just to emphasize, whenever we talk about declines in fertility in China, we usually hear a lot the influence of the one-child policy that was implemented between 1979 and 2013. But it was not only that. It was not a birth planning policy, in this case, the one-child policy. Also, socioeconomic changes, economic development, starts to be more expensive to have children. All those factors influence the decline in fertility. So people will decide to have fewer children, and because of this strong culture that puts the preference on having sons, people use the ultrasound technology to determine, to know what's the sex of the upcoming baby. If it's not a son, they perform an abortion. So that's really common in those societies, even nowadays. And because of that, you have this kind of trend. So see here, the horizontal axis here now is also time from 1980 to 2010. But now we are talking only about sex ratios at birth, only one specific age. How many boys, how many girls were born in that specific year from 1980 to 2010 in Taiwan, China, and US. So in the US, pretty much we have around 100 boys being born for every 100 girls. It varies a little bit across over time, but not as much. In Taiwan, it did increase from the 1980s to the 1990s, but then in more recent years, kind of like stabilized around 110 boys for every 100 girls. But in China, exactly after the implementation of the one-child policy and also all the process of economic development, economic growth that China has been passing through, and people start to have fewer children, and this preference for sons make the sex ratio at birth increase a lot and reaching around 120 boys for every 100 girls by 2010, okay? So this is just to show how that can affect the society. And that's not just to say that there are more men than women. When these babies, they become older and they will try to get married, there are no women available out there for them to get married. I mean, we always see some news. I mean, there are interesting news that come out in major outlets here in the US showing even these marriage markets, people, single men putting advertisement in public parks to show how good they are. Oh, I have a car, I have a house, I'm a good person, please marry me. This is my contact information. So it creates all these things. Then we are talking about the person. And imagine the family structure too. This society starts to decline fertility a lot and tend to have some of them just one child. So in the future generations, they won't have any aunts or uncles, cousins. So that changes the whole society, right? But also the life of the people they were preferred by their parents, but they're going to face issues in the future. So we hear a lot of cases that Chinese men go to North Korea, try to get married and so on. So because there are not enough women in China. So this is something that changes our daily lives. So how demography is impacted by cultural preferences, and then afterwards, how that affects our life in the future years, right? The next topic of this chapter is about this process of population aging. It's pretty much, we are living in a society that now we have better nutrition, we have more access to health services, we have more knowledge about medications, we have more knowledge about the importance of vaccination, we have more knowledge about all these issues of public health issues that we have in our country, and we act in a way to avoid being sick, avoid dying earlier. And all those things make us, on average, live longer. So that increases life expectancy at birth, the average number of years that all of us will tend to live if we experience the mortality rates that our society is experiencing nowadays. And by doing that, by people living longer, in the long term, you are going to have larger numbers of elderly people in the society. Not just the proportion of older people, but really the absolute number of older people will increase over time. And the large numbers of older people in a society specific is not a problem if we do have large numbers of working people, right? But remember the graphs about the old age dependency ratio, even the total dependency ratio. We start to see the old age dependency ratio that was kind of flat and increasing slowly, start to increase a lot. And if these people, when they reach their older ages, and there are a bunch of them, and there is not a good retirement system implemented in the country, and not good health services for them, they don't have good health insurance, that will affect their life in the future. And if when they were workers, they were not able to get good jobs, good education, and have savings and everything, that will affect their lives later on. So it is a problem to have large numbers of elderly people, when the ratio of elderly to producers become high, generating these socioeconomic pressures in the society. And in the life expectancy at birth, we have been seeing increases now because the pandemic, as I mentioned already, it might decrease even here in the US in these next few years. But we have been seeing life expectancy increasing in these last decades, right? That has been the normal trend. But when we say, oh, in that society, people are living on average until 72, 74, 76 years of age, that is just talking about the average age in which people are living to or until. It's not talking about quality of life. It's not talking about are people being able to walk by themselves? Are people being able to communicate? Are people being able to socialize, to enjoy life with friends, family, and so on? Or in the last 10, 15 years of their life, are they really old and incapacitated to really enjoy their retirement ages? So that has been happening a lot in many societies. People that don't have good health habits throughout their life, don't exercise a lot, eat really bad diet, that will affect their life in the future. They might live as long as the other people, but the quality of life is going to be different. But overall, in terms of the projections of the population, in 2020, just last year, the projections already were indicating, I mean, this is data that was estimated based on previous years for the population of last year, but that was observed, that indicated that more than 1 billion people with at least 60 years of age will be present in the world. So 1 billion people with at least 60 years of age right now in the world. And 23% of them are located in China. That's crazy, right? It's like almost a quarter of all this population of people with at least 60 years of age are located in one single country. And around 7.4% of them are living here in the US. And even if you talk about the oldest old people, those with at least 80 years of age, projections indicate that we have like around 150 million right now in the world, and 20% of them are living in China. 1/5 of the world population of people with at least 80 years of age are living in China, and around 9% in the US. So these are huge numbers. And these numbers, I pretty much got them from this table that's shown in the textbook, right? We have in the top there the number of people, the overall population in the world from 2010 to 2050, the number of people with at least 60 years of age, at least 80 years of age, and then in China and in the US. I pretty much just got this number here, 245 million, and divided by this one here, 1.05 billion in the world to get those percentages. And also did I get the 2020? Yeah, and then I got this one here, 28 million divided by 148. And I did the same thing for the US, this number by this, and this number by this. Okay, so it's pretty much a quarter of the population with at least 60 years of age are located in China. It's going to decrease a lot in terms of percentage, so a little less than 25% by 2050, but still showing how China is going to have to deal with the aging population. So you have to implement specific policies that will attend those people. I use Twitter a lot to follow demographers and social scientists, political scientists, and so on. This figure here was posted by this political scientist called Jairo Nicolau. He's a Brazilian political scientist. And he pretty much adapted a figure that was actually first published by The Economist. But just his graph is a little better than The Economist because it better shows the countries there. That's why I'm showing Nicolau's graph instead of The Economist graph. And here, what we are showing, in the horizontal axis, we have the population age 65 years and over as a percent of the total population. So it means that here, let's get New Zealand, almost 15% of the New Zealand population, 2017, was composed by people with at least 65 years of age. All right, so here in the horizontal axis, just showing the percentage of people in those countries with at least 65 years of age in 2017. And what is interesting, the vertical axis, so that's when you start to do social demography, right? The first, when I discussed in the first lecture, when we start to link demography into other areas of our social life. In this case here, we are talking about retirement benefits. In the vertical axis, we are showing the government spending on pension benefits as a percentage of the gross domestic product, as a percentage of everything that's produced in those countries in that specific year. So what I'm pretty much saying is, as we have a higher percentage of people with at least 65 years of age, if everything is working out, we would expect that a higher percentage of everything that's produced in the country will be used to pay retirement benefits to those people, right? That's what we would expect. And that's the general trend that we see in this graph. Countries that have higher percentage of people with at least 65 years of age, they will spend more money on pension benefits as a percentage of all the money that is produced in those countries in that specific year. So Italy, really high, like around 23.5% of the population with at least 65 years of age, and 16% of their GDP go towards pension benefits. But what's interesting from this graph are the outliers. So Japan, as I mentioned before, has the highest life expectancy at birth in the world. So more people will reach older ages. So that's why Japan is right there, above 25% of people with at least 65 years of age by 2017. And they spend 12% of their GDP on pension benefits. So they are in a better situation than all these countries here that have a lower percentage of people in older ages and are spending more with them. They have a better system that tries to optimize the use of money. Of course, we don't want to spend too little money and those people don't have enough resources, but we have to optimize the use. A case to follow would not be Brazil. Brazil has only around 5% of the population by 2017 with at least 65 years of age, and they are already spending 12% of their GDP on pension benefits, the same 12% as Japan. And Japan has like around 27% of the population with at least 65 years of age. So that means that Brazil has to pass by some form of reform of the pension system, because a lot of money that is produced in this country, in Brazil, is being used for pension benefits. But then comes ideology. This discussion has been going on in Brazil a lot, that it's needed, it's necessary to reform the pension system. But then usually more right-wing groups, they want to cut the benefits of a larger population that actually their pension benefits is really small, while usually the left wants to actually cut the pension benefits of the really rich, a smaller proportion of the people, and then it becomes this struggle between the left and right and nothing is done, right? Of course, what you'd like to do for the older people is to have some kind of fair system that the really rich would have lower pension benefits and would be more equal, at least by the end of their life, their possibilities. And in Brazil also, people who retired from government jobs like judges and military personnel, they have really, really high levels of retirement benefits. And that creates this unequal system. And whenever you talk about reforming, those people that have really, really high levels of pension system, they have a lot of influence in the House of Representatives, and then the system becomes even more unequal. So just to show that demography in this graph here, the horizontal axis, has some strong effects and makes some strong pressures on specific aspects of our social life, and that creates a lot of debate of how we should solve these problems, right? So that was the class based on mostly on chapter 10 of the textbook, Age and Sex Composition. The next chapter, it's about world population change over time. You were supposed to have started it last Tuesday and finish it by today. Of course, we're not going to be able to do it. And just a reminder to everybody. So we are here today, starting world population change over time, the chapter 12. And I hope to finish it by Tuesday. And then 1 week from now, we will have our first exam, right? 1 week from now, we don't have the in-person class here. The exam can be taken from anywhere on the computer with internet access on campus, okay? But just remind that 1 week from now, we will have our first exam. If we go only until world population change over time, exam 1 will not cover the chapter about population change in the US, okay? The material of the exam is the material covered on lectures from 1 to 7. If this was not covered, we will not have questions about it, okay? So here in this lecture is a short chapter, and it's kind of like giving us some idea of these 5 contemporary aspects of 5 contemporary changes that we have been seeing, really important in demography, right? So we're going to talk about these 5 major changes that we have been seeing in demography in these last decades, in these last centuries. And we're going to start talking about the demographic transition. What exactly is demographic transition? What are the stages of the demographic transition? And we're going to go a little deeper on the demographic transition on the chapter about theories of demography. And I think it's chapter 2. We go back onto chapter 2. So here I'm just going to show you an overview of the demographic transition, and we're going to go deeper into it when we talk about theories of demography. And so up to here, I think we have around 33 slides. And then we have pretty much the same amount afterwards, another 30 slides about global population trends. They're pretty much the same discussion that we have here, but those slides are from another textbook. And I just wanted to make it available for you if you want to read it. But these specific slides here, I will not cover in the classroom, and I will not ask specific questions that are shown in this portion of the lecture and these slides. I will just cover until demographic transition for this specific set of slides. So what are the 5 contemporary aspects in demography that we want to discuss here? What is called the greatest demographic change in human history is pretty much the huge population growth that we experienced in these last centuries in the human history, right? So many people being born and live longer, that makes the overall population size in the world increase a lot. So the overall size of the population is linked with people living longer. So we have really high increases in life expectancy. And at the same time, in more recent decades, we have been seeing fertility declining a lot. So the population growth that was really strong in previous decades now starts to slow down. Although people are living longer, now people are having fewer children. And on average, women start to have less than 2 children. When the average of a specific population on the number of children is below 2, we say that that country is below the replacement level. And to be more specific, usually when countries are below, have a total fertility rate below 2.1 children per woman, 2.1 children per woman, we say that those countries are below replacement level. That's why the 0.1, exactly because we have the fertility is a measure based on information from women, but we are talking about all the children that they had, both boys and girls. But we know that usually we have more boys than girls, so we need a little more there to have a little bit more girls to replace their mothers when they become older and reach reproductive ages. The 2.1 is also considered this moment where you call, if you're below it, you are below replacement level, because some of the girls that are born, they won't reach reproductive ages. And reproductive ages, as we talked already, for women, the standard in demography is considered between 15 and 49. Some women will die before reaching 15 or before reaching 49. So they don't live all reproductive ages. So you give a little extra to the total fertility rate to 2.1 in order to have more people being exposed to the chance of having children. Another thing that we have seen, and it was the topic of this number 4 and 5 were topics of the previous chapter as well. The unbalanced sex ratios at birth. Some countries experience really high levels of sex ratios at birth. Many more boys being born than girls. And the society exactly linked with the increases in mortality, the increases in life expectancy, decline in mortality, and decline in fertility, we start to see a higher proportion of people in older ages. Right? So we just talk a little bit about each one of these topics in these next slides. So here we see that in between 2011 and expected 2024, we had only 13 years and the country added another billion of people to the world population. It took all these thousands of years to have 1 billion people. And then another 130 years to add another billion. 30 years to add another one. 14, and so on. Just to show that population, even now that we have declines in fertility, the population is still increasing. Only in 13 years, we expect the population to increase from 7 to 8 billion, right? But what is interesting here is to break it down as well by different areas, by different regions, by different countries in the world. And we see that overall, the more developed countries, their overall population has not been increasing so much over time. They're around 1 billion. Africa, the whole continent, has been increasing the overall share in the population of the world, in this case, because the absolute numbers have been increasing. So we have around here 2 billion people. In China, also increased a lot, and now it's tending to stabilize a little more. And India is still increasing, and India will pass China as the country with the highest number of people living in its territory. In other less developed countries, we also have been experiencing an increase in population. And this one here, we are just talking from 1950 to 2050. So it's like these projections based on these previous years, what to expect through these next few decades. But it's just to show how population is so much in these last centuries, in these last thousands of years. But now the increase, we also see an increase going on from 1950 to 2050, but really concentrated in less developed countries, not as much in more developed countries, okay? It's interesting that that Hans Rosling, the one that I always mention him, I put some of his videos in our course website. In some of his videos, he says, oh, we usually have all these classifications of countries, right? Less developed countries, the least developed countries, more developed countries. I prefer to simplify it. If you want to keep the term developed countries, okay, this can be called developed countries. And the other ones, I will call them the world, because it's pretty much the whole population of the world. Like the more developed countries, Western Europe, US, Canada, Australia, really a small percentage of the overall population in the world, right? Life expectancy. Over the past 2 centuries, especially since the end of World War II, we have been experiencing really huge progress on life expectancy, which means declines in mortality. It's the most important thing in human history. It's a consequence and cause of a new way of viewing the world. We have more control of our actions. We have more control of our health than what we could do in the past. And also it's a difference in mindset. So it's a little bit mind-blowing nowadays to see all this discourse against vaccines that happened even before the pandemic. The pandemic, those that were usually against vaccines were usually called the anti-vaxxers. And the ones now that are against the vaccine for the pandemic don't like to be called that because they just think, oh no, this is a really new technology and I'm afraid. And also Bill Gates might put a chip inside my arm and that's dangerous. So it's mind-blowing to think that people actually think that, right? In this world that develops so much in terms of medical advancements and all the science behind us, everything that we are here at the university to learn science, all sorts of science, including social science, within it, demography, right? And that is really related to the worldview, how we think we can control our lives. Oh no, I will live to this superpower that I think has all control over me. But only the vaccine you're going to refuse, everything else, all sorts of medicine that you take, you're going to take it, but the superpower is not making the medicine. Who is making the medicine is science, right? So it's just interesting how all this discourse against vaccines nowadays goes against everything, all the changes, all the positive changes that we have been seeing in the last 2 centuries, right? It's not from yesterday. All this discussion about masks, about social distance, everything, it's not based on, oh, I think, oh, my opinion. No. Science, data, facts, right? And these transitions, the way that we think the world, how we can control ourselves, have been really important in the way that we act in every single day and how we are able to access really high-level modern medicine. We go to the doctor. We try to eat better food. We try to exercise, all based on knowledge, all based on scientific knowledge, right? And that transforms our daily lives. That transforms how long we live and how well we live. Like I was talking about, it's not just about living longer. It's about living well when you reach older ages. And that difference, like living longer, has to do with mortality. And living longer without serious diseases has to deal with morbidity. Morbidity is about the incidence of diseases. And just to give an example about life expectancy, how people have been increasing a lot their life expectancy over time. And here is just to focus on some examples of developed countries. Japan in red, US in gray, and Denmark in light and dark yellow there. So we see increases over time, and Japan starting lower, and right after World War II, increasing a lot and passing the 2 countries, and always women living longer than men in Japan, in Denmark, and in the US, okay? So life expectancy has been increasing over time, and this is the information that have been talking to you, that already some demographers are projecting the life expectancy have been seen here increasing over time, and in the US are these 2 gray lines, so for men here and for women here, that we might see some declines exactly because these really high levels of deaths due to the pandemic that we are experiencing right now, okay? So this is huge. And when you have this trend going up, and then at a certain point it declines, what's going on? And that's this exogenous effect that we're experiencing right now since last year with COVID-19. It will be interesting to see these graphs updated. The third topic, decline in fertility. So a lot of countries are reaching women having less than 2.1 children on average. And that is really associated with the level of population growth. More specifically, here in this graph, we are seeing the population growth rate from 1950 to 2010. So the population growth was kind of like around 1.8% per year back in the 50s. It increased to more than 2% in the 70s, and then it started to decline. And the period of most rapid population growth is behind us. It was around the 1965 and 1970. And the growth rate has declined, falling roughly by half in 40 years as women start to have fewer children. So this decline here in population growth rate is really related to women having children, the graph in the bottom. So this is just showing the total fertility rate. What is the total fertility rate? The average number of children that women would have if they experience the levels of fertility in a specific country, in a specific year. And in this case, we have the information for the world falling from 5 children per woman in the 50s and going down to less than 3 by around 2007. And more developed countries already going below the replacement level, below 2.1, and less developed countries also declining a lot. In this case, you should not be biased by China because of the really high population of China. This dark red line here are the less developed countries excluding China. So the global fertility rate has dropped from 5 to 2.5 children per woman in roughly these 50 years. And the average woman in developed countries now, they have around 3 children, down from 6. So from 6 declining to 3, right? So that's a huge decline in fertility, and that influences the decline in population growth rate. Cool. The fourth topic, the unbalanced sex ratios at birth. This is just other examples for the same thing that we saw before. Here, this data we are showing from 1949 to 2005 for India, South Korea, China, and this specific area in India, and showing how sex ratio, this is not just sex ratio at birth, it's sex ratio among people between 0 to 4 years of age. And all of them are above 105. India kind of below, and actually in the more recent years going above 105. And remember, the 105 is considered kind of like the overall average of sex ratio at birth if there is no specific action for preference for boys. And in this specific province in India, in China, in South Korea, you have really, really strong sex ratios for these children between 0 and 4. And South Korea kind of declined a little bit in these more recent years. So these unbalanced sex ratios at birth, it affects how families are formed, as I just mentioned before, in terms of finding a partner, in terms of having other relatives, aunts, uncles, cousins, and so on. That affects our support from the family later in life as well. Cool? And like I mentioned, biological normal level of sex ratio at birth is around 105 boys being born for every 100 girls. Several societies have much higher because of rapid fertility transition in a culture that has preference for sons and now availability to ultrasound to determine the sex of the fetus. It is the access to abortion because they prefer to have boys than girls, right? And this is the total fertility, the trends of total fertility rates in China from 1950 to 2010. And we see that the fertility in China was around like 6, like before the 70s, and even before the implementation of the one-child policy. The one-child policy was in 79. You already saw a decline in fertility a lot. So that's why demographers mention it's not just the one-child policy. It's also all these changes. It's also because all these changes that China is experiencing in society, in terms of economic development, urbanization, people tending to have fewer children. And like I said before, even with the one-child policy, the total fertility rate in China still was around 2 children per woman. It declined a little bit lower than 2, but it did not reach exactly 1, right? Because there were a lot of exceptions that women were allowed to have 2 children. Even if they were not allowed, they would have more children, and then one of the kids could not attend or get access to specific public services. So, but overall, the fertility in China still was around a little higher or a little lower than 2 children per woman, even after the implementation of the one-child policy that already ended in the country, after this graph here. Why does China have high sex ratio at birth? Prenatal sex identification via sonar technology followed by female-specific abortion. What will be the result of the high sex ratio at birth? So trying to see how demography might affect society. The post on the author of the textbook, he has like a lot of, he did a lot of research about China specifically, among other regions in the world, including the US, of course. But he started to see, in terms of the projections of this population, between 1983 and 2010, over 41 million extra boys were born than girls in China. So, related to what I said before, a larger number of bachelors in China than the total population of California or Texas. And a lot of these guys going out of the country to try to marry women in other places. So all that create all these issues. And he also goes on. He tries to see what's going to actually happen in the life of these people. Most men, do you remember when I talk about the marriage market? People going to public places, public parks, and putting a post about their qualities, their assets, trying to find a person to marry. And those that don't find someone to marry are usually the poorest ones with lowest levels of education. They are unemployed, or they have really bad occupation, like low-paying occupations, and they usually migrate from rural to urban areas. And I mentioned to you before, in China, in order to move from one place to the other, and usually people try to move from rural to urban areas, you have to have the permission of the government. But what happens is that a lot of people move even without that permission. And by doing that, they don't have access to the formal labor market. So we get low-paying jobs. They won't have access to a series of services that they have there. They even leave their children and other relatives back from where they came from, because otherwise they would not have access to public services, right? Being poor, uneducated, no perspective in life, that might increase crime, violence, increase prostitution. And the increase in STDs has been a real problem in China, especially among unmarried men. And there is an unprecedented spread of HIV in the country as well. So see how demography, how this culture of some preference and this unbalanced sex ratio at birth can generate or is associated with all these other issues in the society. In sub-Saharan Africa, here, like Poston, he tries to compare the level of HIV in Africa, in sub-Saharan Africa. That's where we have the highest levels of HIV to China, some projections that they have done for China. In 2013, Sub-Saharan Africa, 24.7 million adults were infected with HIV. This is almost 71% of adult infections in the world. In 2010, specifically, around 1.2 million people died from AIDS and 1 million people became infected with HIV in Sub-Saharan Africa. And China, based on some projections, could equal or exceed these numbers by 2030. The country now is beginning to take serious measures in order to deal with HIV and AIDS, right? And of course, the COVID-19 pandemic comes in the middle of all that as well, right? The fifth point, population aging. I showed you age-sex structure in the previous chapter and showing how countries are experiencing fertility decline and mortality decline. So the shape of the age-sex structure stopped being as a pyramid and start being more rectangular. And if you compare developing countries in 2010 with developed countries, you see that really clear. And when you put the population in millions, not just in percentage, you also see not just the difference in shape, but the difference in size of the population, right? The shape of the pyramid here in developing countries is more triangular. Now some older cohorts are kind of the same size of this one's, kind of showing like a decline in fertility as we saw in the previous slides. But more than that, and in developed countries, you actually see a similar number of people in older age groups as you see in younger age groups. And in terms of the length of these bars, the population in developing countries much larger than in developed countries, right? And some other statistics here, 43% of the population less than 15 years of age, they live in sub-Saharan Africa, and only 16% of the population with less than 15 years of age live in Europe. So many more younger people living in developing countries than in developed countries. In this case here, focusing on sub-Saharan Africa and Europe. On the other hand, older people, 3% of the people with at least 65 years of age live in sub-Saharan Africa based on data from 2010. And already around 16% of people with at least 65 years of age living in Europe by 2010, right? So kind of showing there is a population aging going on, but at the same time, there is variation across countries, across regions in the world, across continents. Another way to show population aging, this graph here, we have the percentage of population with at least 60 years of age. And we have the first bars here for the world, increasing from 1950 until the projections to 2050. More developed regions, even higher percentage of people with at least 60 years of age. Less developed regions have lower percentages, but these percentages have also been increasing over time, reaching 20% of people with at least 60 years of age in less developed regions expected by 2050, okay? And then we enter in the second topic of this chapter, the demographic transition. As I said here, I'm gonna give a big picture, and then we're gonna come back when we talk about the chapter on theories of demography. Usually, demographers, whenever they are talking about the demographic transition, they are talking about changes in birth and death rates. In previous societies, pre-industrialization societies or pre-transitional societies, the birth and death rates, they were really, really high. In some cases, you had even more people being born than dying, or some cases you have more people dying than being born, but in really, really, really high levels. In that case, since you had both really high, one kind of offsets the other. So the population growth is not so steady, it's not so steep, right? Because birth and death rates are so high that the difference between the overall number of people being born and the overall number of people dying in a specific year in a specific country was really close to zero. So the population doesn't grow as much. The demographic transition starts to happen when we see really huge declines in mortality. And the first declines in mortality are experienced by the younger people. Infant mortality rates decline a lot all over the world. Of course, it starts to decline first in developed countries. So whenever we start to have some measures that provide sewer system to the societies or treated water, basic infrastructure, that makes the number of people dying due to communicable diseases or infectious diseases decline a lot. So what you start to see is a decline in the death rates. The death rates decline a lot in this process, this stage called transitional stage that happens during industrialization, modernization. Exactly during industrialization, the Industrial Revolution, we start to have public infrastructure, like I just said, treated water, sewer system, basic measures when we are having birth with like clean, in a clean place, people washing their hands and everything, that makes children live longer. Incidence of communicable and infectious diseases decline. And decline so much, and the birth rates don't decline a lot in that period. Do you remember the basic demographic equation that we saw in the first class in the semester? When you get the birth rate and subtract, or the number of births, and subtract by the number of deaths, what do you have? What's that indicator? How is it called? If you don't remember, just read the slide. Natural increase, right? So number of births minus number of deaths, natural increase. The natural increase here is huge because mortality decline. The birth rate might decline a little bit, but not as fast. And then when people start to realize, hey, it's expensive to have children, to have 6 children. And we don't have to have so many children for them to survive to older ages. We can have fewer children, both because it's expensive and also because they will reach older ages, 2 or 3. Then fertility starts to decline in this third stage. And what happens? Natural increase kind of declines. Birth rate minus death rates declines here. So the population doesn't grow as fast as we saw here. And then you finally reach the stage 4, called incipient decline, in which countries reach so low levels of mortality and fertility that in some cases you might experience population growth or population decline, right? But now really low levels, not so high levels as we saw on stage 1. So this graph here, I took it from the textbook. And this graph here is showing the demographic transition in 4 stages. All questions that we will have on quizzes and exams about demographic transition and talking about stages, I will use this idea here, stage 1, 2, 3, and 4, and these names here. This next slide kind of break down the stage 3 into or stage 2 in these two parts here, right? It kind of breaks down the stage 2. So that's exactly what I said before. Compared to the previous slide, this is the previous slide. This one here is breaking stage 3 in these two parts. I don't want to confuse everybody here, but the questions that we will ask about, whenever I'm talking about stage 1, 2, and 3, and 4, I'm talking about the previous one. Why am I showing this one here? Because this one, the authors add a third line, the total population, which is related to the natural increase. So birth rate really high, death rate really high, one minus the other, population doesn't increase as much. Mortality declines really, really fast. Birth rates don't. Birth minus death, population increases really fast. Then when we start to see fertility declining, birth minus death, you still see population growth, but not as strong, not as steep as we saw in the stage 2. And then some countries where you might experience so low levels of fertility below the replacement level, really low levels, around 1.3, 1.4 children per woman, and people living longer, you might even experience depopulation, decline in total population, right? But overall, you pass from stage 1 of high birth rates, high death rates, and kind of a stable or a slow increase in population size. Birth rates still high in stage 2, death rates fall really fast, and you have this huge increase in population size. And then as fertility starts to fall and death rates are already kind of low, the population starts to increase a little slower and tends to be more stable in the coming decades. And afterwards, the very low levels of fertility and mortality make the natural increase being either stable or even negative over time. All right. Sorry, I didn't know what to do here with the microphone. Sorry about that. So I just wanted to show this graph to emphasize this curve here, the total population, how the total population increases a lot due to this huge natural increase that we see on stage 2 because mortality declines so much. And related to that, there is this term that demographers use a lot called the doubling times. If the population keep increasing in the rate that we see today, how long time would it take for the population to double in time? If it was the opposite, if we see a population that is declining in size over time, if this population keeps declining in that path over time, how many years would it take to the population to be half of the size of what it is today? That would be the half in time. How do we calculate that? The doubling time and the half in time. That's what this formula is trying to do here. So what is the doubling time? Is the time it would take a population to double at a given growth rate, if the exponential model were exactly true. And this rule here is called the rule of 69.3, related to the formula that we're going to see here now. So what we are trying to do, let's say that we have a population right now in time 0. And we want to know the population in time t in the future. If I don't have information about migration, I have just information about fertility and mortality, to simplify. Or I could have about migration too. I mean, let's just say that I know what's the population growth rate in a specific place in these previous time points, in -1, -2, -3. And now on time 0, I have a specific population K0. And this population is experiencing population growth rate expressed here by the R. And this growth rate is a growth rate for every year. The T here is talking about every single year. If I'm talking about from 0 to the next year, 0 to 1, T expresses 1 year. But I can leave it more generic as a T to kind of say, okay, if I have this population now in time 0, I have this growth rate here. If this growth rate does not change and keep being the same in the next decades, how many years T would it take for this number here be the double of this number? That's the exercise. So what we are trying to get? The time in which the population will double in size. What exactly is the double? It's going to be 2 times this number here. I want to know how many years T we will increase this population from K0 to 2 times K0 if I keep this population growth rate. So what I'm trying to look is when this one here equals 2 times K0. So I'm going to have this one substituted by 2 times K0. And I have here the exponential and population growth rate and the time in which my population will double from K0 to 2 times K0. And K0 is multiplying both sides of the equation. I can just cancel them here. I have 2 equals exponential of growth rate times the time in which the population will double in size. Since the right side of the equation is an exponential, to get the exponential out, I just take the log of this in order to have population growth rate and the time that it would take for my population to double in size. Why do I want to get out of the exponential here? Because what I'm interested in is on T. I wanted T by itself in one side of the equation. Since I took the log of the right side, I take the log on the left side. Log of 2 is right here. What I'm interested in is in the time that it would take for the population to double in size. So I will leave this one by itself in one side of the equation. R is multiplying here, goes to the other side, dividing. So the time that the population will double in size from K0 to 2 times K0, if my growth rate stays stable, it's pretty much log of 2 divided by R. Log of 2 is 0.6931, then divided by R. If, let's just round it up here, log of 2 equals 0.7. If we have a growth rate of 1%, a growth rate of 0.01, 0.01. How many years, if that population keeps growing at 1% per year, or 0.01 per year, how many years will it take that population to double in size? 0.7 divided by 0.01. How many years? 70, right? It's simple. If you round this up to 0.7, you just divide 0.7 by that growth rate. Cool? So if this population keeps having this same population growth rate for the next decades, we just apply this simple formula here, and then we can have an idea of how many years the population will grow into the double. I will give examples in the next slide here. 2 p.m. Have a great weekend, and I see you guys on Tuesday. Thank you.